In this video, we're going to apply the substitution method to solve a few more integrals. The first question is, show that the integral 1 over x squared plus a squared integrated with respect to x is equal to 1 over a arctangent of x over a plus c. So let's rewrite the integral 1 over x squared plus a squared dx as, let's divide everything by a squared. So x squared gets divided by a squared gets divided by a squared, and 1 gets divided by a squared. So we get 1 over a squared divided by x squared over a squared plus, and a squared over a squared is just 1, integrated with respect to x, and 1 over a squared is a constant, comes out of the integral. We get 1 over x over a squared plus 1 dx. So now that we've done some algebra, we're ready for the substitution method. We're going to let u be equal to the inside function x over a. du is going to be 1 over a dx. If you solve for dx, we get dx is equal to a du. Multiply both sides by a. Alright, so we have 1 over a squared integral 1 over x over a all squared plus 1 dx. This is equal to 1 over a squared integral 1 over x over a is the variable u. That's the variable of substitution, u squared plus 1. And dx is a du. A is a constant, passes through the integral. And we're going to get a over a squared integral 1 over u squared plus 1 du. A over a squared is going to be 1 over a integral 1 over u squared plus 1 du, and that's 1 over a tan minus 1 arctangent tan minus 1 of u plus c. Now substitute u back in, and we get 1 over a tan minus 1 of x over a plus c. Alright, so what we have shown, we have 1 over a integral 1 over u squared plus 1 du. That's 1 over a tan minus 1 of u. We substitute u back in, and we get 1 over a tan minus 1 of x over a plus c. So what we have proven here is that the integral 1 over x squared plus a squared integrated with respect to x, that's going to be equal to 1 over a tan minus 1 of x over a plus c. Let's look at an application of this. Here we have integral of 10 over x squared plus 4 dx. The first thing we'll do is pass the 10 right through the integral, so we get 10 integral 1 over x squared plus 4 dx. Now what we have is we have 10 integral 1 over x squared plus 4, but we can write the 4 as 2 squared. And now you can see that we can apply the formula with a equals 2. So a equals 2, and we're going to use that. Alright, so the result will be 10 times 1/2, 1 over a, tan minus 1 of x over a, tan minus 1 of x over 2 plus c. So we actually applied a equals 2 into this formula here. So the result is 5 tan minus 1 of x over 2 plus c. Alright, let's look at another example. Here we have evaluate 1 plus root x to the power of 20 integrated with respect to x. We're going to let u be the inside function. U is equal to 1 plus root x. du is going to be, applying the power rule, 1 over 2 root x dx. And if we solve for dx, we get dx is equal to 2 root x times 20, times du. And now our goal is to get dx entirely in terms of u. So notice that root x is equal to u minus 1. So we can rewrite dx as 2 times u minus 1 du. Alright, so what we have is integral 1 plus root x to the power of 20 dx. 1 plus root x, that's u, so this part of the integrand is u to the 20, and dx, this part is 2 times u minus 1 du. So we have integral 2 times u to the 20 times u minus 1 du. 2 is a constant, passes through the integral. We get 2 times, and u to the 20 times u to the 1, the powers add up, the exponents add up, and we get u to the 21 minus u to the 20 times 1, that gives us minus u to the 20. And now integrate this piece by piece, and we get 2 times integral of u to the 21, reverse the power rule, that's going to be u to the 22, divide by 22, minus integrate u to the 20, and that's going to be u to the 21, divide by the same, 21, plus c. Now let's substitute u back in. U is equal to 1 plus root x. So the result is 2 times 1 plus root x to the power of 22, divide by 22, minus 1 plus root x to the power of 21, divide by 21, close the bracket, plus c. All right, let's look at one last example. Here we have integral x over x plus 1 to the power of 10 integrated with respect to x. We're going to let u be the inside function like usual, u equals x plus 1, du is equal to dx. Let's solve for x in terms of u. X is equal to u minus 1. Now let's rewrite the integral. We have x over x plus 1 to the power of 10 integrated with respect to x. So that's going to be equal to, we can replace x by u minus 1. So the x becomes replaced by u minus 1 divided by x plus 1 is u to the 10, and dx is just du. So what we have done is this part x is replaced by u minus 1, and the denominator x plus 1 to the 10, that's just going to be u to the 10, and dx is just du. All right, we're going to split up these fractions. We're going to get u over u to the 10 minus 1 over u to the 10 integrated with respect to u. Simplifying, we get integral u to the 1 minus 10 is negative 9 minus u to the minus 10 integrated with respect to u. We're going to get u to the minus 9 plus 1 is minus 8, divide by minus 8, minus u to the minus 10 plus 1 is minus 9, divide by minus 9, plus c. So the result is negative 1 over 8, u to the 8, plus 1 over 9, because the minuses cancel out, becomes plus 1 over 9 times 1 over u to the 9, plus c. Now let's plug u back in. U is equal to x plus 1, so we get negative 1 over 8 times x plus 1 to the 8 plus 1 over 9 times x plus 1 to the 9 plus c. This is the antiderivative. All right, thanks.